Hello and welcome. If you've spent time around storm-related sites or videos, you've no doubt seen or heard terms like QLCS, squall line, bow echo, and derecho. In this video I will give some general information on what they are and the differences between them. This video was purposely kept simplified. It is meant as basic information only, not a learning tool or expert advice. Convection. In weather, convection is upward movement of air. A convective storm is a storm built by convection. In most cases this refers to thunderstorms, but not every convective storm creates lightning and thunder. This convection is generally created by surface heating. Sunlight heats the ground and surrounding air. This warm air is less dense and naturally rises above the cooler air surrounding it. It also brings with it water vapor or humidity. As air rises, it cools and releases energy. The cooler air gets, the less moisture it can hold, so as it cools its humidity rises. Once it has cooled enough to reach 100% humidity, it is considered saturated, or in other words to have reached its dew point. As it cools further beyond this point, the water vapor will start to condense out of it and into liquid water droplets. These tiny droplets along with dust form the clouds you see, and in turn lead to precipitation. This whole process is very complex, and far more than I would be able to go into. An entire video could be done just on this one subject. Cell. A storm cell is a weather system with its own internal updrafts and downdrafts. It can be an independent single thunderstorm, or one part of a multi-cell thunderstorm or system. QLCS. QLCS stands for Quasi-Linear Convective System. It is a line of convective storms that generally forms along a cold or other boundary, but does not need to be either, as these systems can generate their own weather. It also does not have to be a straight line, hence the word quasi in the name. In addition, it does not have to be a continuous line. There can be space between individual cells or groups of cells. But in such cases, it must still act as a single system. A QLCS can be made up of ordinary cells, or be a mix of ordinary cells and supercells, or even in rare cases be all supercells. Any of these variations can produce heavy rain, hail, damaging winds, lightning, and even a weak tornado, with lines containing supercells having a better chance of producing a stronger tornado. Bow echo. A bow echo is a form of QLCS. On radar reflectivity it will have a bow shape. A segment of the line can be bowed like in this image. Or the entire line can be bowed like in this image. Over time these systems will tend to form line and vortices rotating in opposite directions. These are also sometimes called bookend vortices. A system such as this will develop a rear inflow jet or RIJ, which is airflow pulled into the back of the system. A shorter, more compact bow echo will generally have a stronger rear inflow jet than a longer one, due to the closer relation of the line and vortices. To keep things simple, I am going to leave it at that, as an entire video could be dedicated to just Squall echoes. Squall line. Squall line is for the most part just another name for a QLCS. LEWP. LEWP stands for line echo wave pattern. This again is a form of QLCS. It is simply a line with more than one bow echo. An example is shown in this image. Derecho. A derecho is a QLCS that produces a damaging wind path at least 250 miles long and 60 miles wide. Has winds of at least 58 miles per hour along most of its length, plus several well-separated gusts of at least 75 miles per hour, and lasts for at least 6 hours. MCS. MCS stands for Mesoscale Convective System. This is a somewhat general term for a long-lasting organized complex of convective storms. They can take on a round or linear shape. A QLCS is one example of a form of a MCS. A hurricane is another. MCC. MCC stands for Mesoscale Convective Complex. A MCC is a MCS which is generally round, has area of plow tops larger than 39,000 square miles with a temperature less than -26°F, and an area of plow tops at least 19,000 square miles with a temperature less than -62°F. These sizes must last for at least 6 hours. MCV. MCV stands for Mesoscale Convective Vortex. It is a low-pressure center or meso-Wojtyła MCS, with winds in a rotating pattern or vortex. A MCV can persist for up to 12 hours after its parent MCS dissipates, and can serve as the initiation point for another round of thunderstorms. That's all for now. Hope you enjoyed the video, and got something out of it. This turned out to be far longer and more complex than I had originally planned. Thanks for watching.